This video is going to introduce you to similar figures, how you can tell if figures are similar or not. And when we're talking about similar figures, we're talking about polygons. First thing I think we should do is make sure that you know some basics about being similar. First off, that's a symbol for similar. And when we talk about shapes being similar, basically all we're saying is that one is a scale model of another. So hopefully that will help you understand that what we're doing is changing the size. So when we have a shape that is a scale model of another shape, it is just a difference in size. So two parts that have to happen that will make things similar is, first off, corresponding angles are going to be congruent. So corresponding angles are congruent. So hopefully you know that that is the symbol for congruent. And then the other thing that's going to happen when we have similar figures is that the corresponding sides are proportional. So corresponding sides are proportional. What that means is that, hold on, let me finish writing, okay? What that means is that we have a scale factor. So basically when you have a scale model, and what we were doing when we were just dilating figures is, in order to make a scale model, things have to be proportional, which means that we have a scale factor. And the scale factor is what changes, or what is the proportion that we're talking about with the sides and angles. So every triangle has, we're going to concentrate on triangles, every triangle has 3 sides and 3 angles. And what we're going to do is match them up to be the corresponding angles and the corresponding sides. And you can do that with the symbols that you guys are used to seeing on your shapes from middle school math. So first, let's mention about the corresponding angles are congruent. If you think of a square has 90-degree angles, whether it is that big or this big. So when we say that the angles are congruent, these two are squares, even though they're different size squares, because their corresponding angles are congruent. So if this is side of 1, we know that those 4 sides are all 1. And let's say this side has a length of 2, we know that all of those sides are 2. So the scale factor is going to be 2. This square is 2 times bigger than that one. So I'm also going to help you to figure out scale factor, and the easiest way to do that, so I'm going to say that scale factor is, it's new over original. And if you set up new over original, that will always give you the scale factor. So new over original, new over original. So if this is our original shape and this is our new shape, then the new shape side is 2, the original shape side is 1, so the scale factor would be 2 over 1, which is 2. And the scale factor is what we use when we dilate shapes, which is what we just got done going over. All right, so again, when we look at 2 triangles, we can match up the corresponding sides and the corresponding angles just by looking at the symbols on the triangles. So let's just make sure you're okay with that. If we had this triangle right here, which I'm going to call ABC, and then we had this triangle right here, which we'll call XYZ, then what we're going to do is we're going to look at the symbols that are on the triangle to help us match them up. So for example, if we had something like that, and let's say maybe we had this mark right there. then what we can do is we can look and see that angle A and angle X are the ones that correspond with each other because they have the same marking. And angle B corresponds with angle Y because they have the same marking. And angle Z and C correspond with each other because in this case, they still have the same marking. Going with the sides, if we look at this, AB is the side with 2 marks to 1 mark. So AB would match up with XY. And then if we said YZ, YZ would match up with BC because we're going from 1 mark to no marks. And then if we said angle CA, side CA, that would match up with ZX because we're going from no marks to 2 marks. So that's how we can identify what the corresponding sides and the corresponding angles are when we're looking at our shapes. Okay, so first off, let's do a pretty basic example here. Let's say that we are going to look at 2 triangles and their angle measurements. So let's say my figure does not look like it at all, so we'll just pretend that this is 96 degrees, and we know those 2 angles are the same, and let's call this M, N, O. And then we have a smaller triangle, and I'm going to say that this is 42 degrees and that's 42 degrees. And we'll call this RST. All right, so first thing we're going to talk about is matching up the similar or the congruent angles. So when we look at corresponding sides and corresponding angles, we'll use that in just a minute to name them. But right now I think we should do the math behind it. So the easy thing here is hopefully you remember that a triangle is 180 degrees. So if we took 180 degrees and subtract 96 degrees, we would end up with 84 degrees that would need to be split in between 2 angles. If we look at this triangle and we know that a triangle has 180 degrees and we're going to subtract the 84 degrees that we already have, that would leave us with 96 degrees for this angle. So what we can do by just simple math is identify that these angles right here would be 42, 42, 96. These angles in this triangle are going to be 42, 42, and 96 as well. So now we know that the triangles are similar. So what we're going to do when we write our answer is we would say that triangle. Now, it doesn't matter how you name the first one, so I'm just going to go MNO. But it does matter when I write the second triangle because I need to match up the corresponding angles to each other. So angle M and R would match up, and then N would match up with S, so that comes next, and then O matches up with T, so that comes next. So this tells the reader that MNO matches up with RST. And so what that does is that helps us realize which angles are matching up with which. All right, let's look at one with proportional sides. So for example, 2. So give me just a minute to draw this out. So let's say that we had this, something like this, and let's say this side is 8, this one's 10, and this one's 12, and I'm just going to call this ABC. ABC. And then let's say we have this one, which I made a little bit too big, but that's okay. Let's call this XYZ. And I'm going to say this one is 4, 5, and 6. So this one should be pretty obvious, but that'll help us get our information set up correctly. All right, so if we go back to up here where I mentioned scale factor, we want to do the new shape over the original shape. Well, in general, this one is always the first one is always the original one. So this one would be in the original triangle, and this is the new triangle. So what I'm going to do is I'm going to list the new sides first. So if we look at these sides, I'm going to put them in numerical order. So I'm going to say side 4, 5, and 6. So 4, 5, and 6 of this triangle over, and I'm going to put these in order, and putting these in order would be 8, 10, and 12. So I have small, medium, large of this triangle matching up with small, medium, and large of this triangle. So when we go to reduce these, that will determine whether our triangles are similar. So this one reduces to be 1/2. This one reduces to be 1/2. And this one reduces to be 1/2, which tells me that the sides are in proportion and the scale factor is 1/2, which means that the new shape is half the size of the original shape. So this is what we mean when we say the sides are in proportion. So to finish this problem, we would say that triangle, and remember, we can name it however we want. So I'm going to name it BAC, just to be a little different, is similar to triangle. All right, so now angle B matches up with Y, angle A matches up with X, and angle C matches up with Z. So BAC is similar to YXZ. Now, what that also tells someone if they're looking at this is, and let me see about getting some markers here, BA matches up with YZ. So BA matches up with YX. Sorry, that's an X, not a Z. I swear. All right. Then we can tell that side AC should match up with XZ. So AC should match up with XZ, and it does. And then for the last one, we would see that BC should match up with YZ. So BC matches up with YZ, and it does. So that shows you that the shapes, those two triangles, are in fact similar because the corresponding sides are in proportion. All right, so here's the deal. We can do this pretty easily just by looking at some things that we know. If we know two angles of a triangle, we can use simple math to figure out the third angle. So as long as we have two angles of any triangle, we can determine if the two sides are similar, if the two triangles are similar. So if we knew that these two angles were 42, we could figure out that this one's 96. If we know that's 96 and that's 42, we can figure out that the missing one is 42. So as long as we have two angles, we can show that the triangles are similar. All right, another thing that we can do is look at the three sides. And what I would always do is put them in order. Remember, new goes on top. So put them in order, 4, 5, 6. Put these in order, 8, 10, 12. So then you know that that should be the way that they're matching up. And then reduce it. If you get the same fraction, then you know the sides are proportional, and that fraction is your scale factor. All right, so what we can do is a lot of different things that you guys have learned in Math 8 will allow us to figure out if two triangles are similar in other ways, and that's what we'll be working on next.